What we can do is clean up our heat exchanger. So I use the plastic brush for that. There's a lot of dust on this. So that inhibits heat transfer. So now I've used all three of these brushes I bought as a set. I'll put a link to those too. The brass brush I use on the print nozzle. And then this looks like steel brush I used on the stainless steel parts on the printhead. And some of the parts had this black stuff. It reminds me of, in Star Wars they always talk about carbon scoring. This is like a bunch of carbon that's just encrusted on these parts. So by using this steel brush, I can kind of get some of that off of there. I also used my X-Acto knife to kind of scrape it off. You notice Luke Skywalker, when he's cleaning up R2-D2, he's using like a little scraper, getting rid of the carbon scoring. So that's what we're doing with our printer. Anyway, so now this heat exchanger will be clean, and it'll get better heat transfer. So we're looking good to put everything back together and have our brand new printer. You can take it apart just about everything on this printer so far. Okay, we've got all the parts we need to put everything back together. So we got our new printhead, aluminum block. We've got a new nozzle that screws in. We saved the, I'll put that away for a second. We saved the set screw from the old one to hold the heating rod. Here's the heating rods. The heating rod's going to go in here, like that. Then the set screw will hold it in place. And we've got our heat break tube. We didn't get a new one of those. That screws in the top here. They do supply a wrench for this, which I remembered later. So this is the right size wrench to tighten this up. And we're going to tighten this up pretty well because we put on this cooling block. We don't want this thing spinning around, so we're going to make that pretty tight. Take it out for now. And the final thing we needed was this. We didn't really need it, but I think it's better to have it. We got this boron nitride paste from Slice Engineering. I got this from Matter Hackers. It's on Amazon, but Matter Hackers had faster delivery and it was cheaper. So it comes with a syringe of 5 milliliters. That should be plenty. It's got a cap on the end, and it's got this cross thing connected to the plunger. Then they give you this other longer plunger that also has a cross thing, but these don't really mate together. I guess you push this one. You push this one down as far as it goes. You can go with your finger, then you stick this in, and it'll kind of push it from on. But I don't know why this has a cross section on it. And actually, one of these legs broke. I don't think that's really going to affect things. Of course, nothing will come out until we unscrew this. I'm going to be using gloves because boron. I'm not really that familiar with boron. It's not that common. So it's probably fine. It's just probably safer to use gloves. They also give you these little I would call them advanced Q-tips. So these should be nice for spreading inside here, because we want good conductivity between the heating tube and the aluminum block, and we also want good conductivity between the heating tube and the cooling block. So we want to be able to make sure heat is being added here as efficiently as possible, and also being removed up here in the heat break tube. So using it in both places. It also acts as an anti-seize lubricant. So anywhere there's threads, it's probably a good idea to spread a little bit on there. So, and it's not electrically conductive, which is important. So, because there is electricity floating around here. So use it there. We'll also use it when we screw in the nozzle. Why not? Put a little bit on here. And we'll put on these threads too, of course. Yeah. I won't bother with the set screws. It's too small to worry about, I think. Plus, when you take a set screw off, you got all this leverage, so I'm not really worried about that. And we got to screw the thermocouple back in. There's the thermocouple. So I'll probably put a little bit on these threads just to get better heat transfer between the thermocouple sensor and the heating blocks. All right, so let me get all set up for that with gloves, and then we'll start putting it back together. I decided to just use a regular Q-tip. Save the high-tech ones for the high-tech stuff. This is just wiping off the excess, so it's not any big deal. All right, that's good enough. Okay, so now we got this together. Now we're going to put the heating rod back on. So it goes this way. So we'll put the thermocouple in first. So here's the thermocouple. It screws in. It's got a little brass. Looks like it's brass. So we'll see if we have enough that's left over on this Q-tip. High-tech Q-tip. This is a high-tech job. So it's probably really unnecessary, but it is an anti-seize thing. So it'll make it a little bit easier to get the thermocouple out next time. So that's probably plenty. I'll put that pointing up so it doesn't drip out. All right, so now this screws in to our heating block. Goes in smoothly. So the boron nitride also acts as a lubricant, like you said. So all these things are screwing in very easily. So that's good. We don't want to strip any more threads. Like this snug, using our needle nose pliers. Okay, and that's nice and snug, so we'll get a good contact. Now we're ready to put our heating core back in. So that's just going to slide in like that. So we're going to put some boron nitride on the heating core. And we'll spread it around with our high-tech Q-tip. All around the outside. So this is going to fill in any small gaps that are in this, between this and the actual heating block. A little bit on the bottom too, I think. Spread that around. We can concentrate toward the tip because that's going to be where it's pushed in first. A little bit more in there. This is the most important heat transfer surface here, so I want to make sure we do a good job on this one. So I'll put a little extra blob at the tip here because that's when it's going to go in first. It'll spread out as it goes in. So then we can use the excess we've got here, I think, and just wipe it around the inside of the cooling block. See if I can show that. Yeah, so inside the cooling block, we'll just wipe off any excess we have. So now we got it on both ends. It slides in here. And it was pretty much seated in there, so I'm pushing it all the way in. Then we use our low-tech Q-tip to wipe off the excess on this side. And we use a rag here in a minute to get anything else off. So, all right, so this actually went over the top of this one, so let's put this underneath there. Actually, let's have to do that. Let's see. So it's like that, I guess. Okay, so now this is all the way in. Then we'll use our Allen wrench to tighten it up. So it's seated, and now we're going to use the short end to give it some more leverage. Tighten it up well. Don't want it moving around. Let's do it that way. And we just use our rag. Wipe out the excess boron nitride. Let's see, are we done with the boron nitride? I think we are. So I'm going to set this down. Oh no, we still need a little bit on here. We'll probably have enough on our high-tech Q-tip, so I'm going to go ahead and stuff kind of dries out. That's interesting. Pretty liquidy when it comes out, but it dries out in the air. So I want to put the cap back on this so doesn't blob out anymore. So you can see we only use a tiny bit. So this is basically what will last the lifetime of this printer easily, and maybe the 2 or 3 printers after that easily. So okay, so now we're ready to put our nozzle in, but we obviously don't want to forget our heat break tube. So I'm going to cut away here and show you how I cut this to the right length, and then we'll come back and put the nozzle in with the heat break tube, and then we'll be almost ready to put it all back together. Another thing we can do while we're waiting is cut our new heat break tubing. And this Teflon is basically impossible to draw on. If you use a magic marker or a pencil or whatever, nothing sticks to Teflon. That's the whole point. So it's basically impossible to mark this where you need to cut it. So what I've been doing lately is I use this X-Acto knife to make a little score right there. And then I can use my tubing cutter, line up with that score. It cuts it off nice and square. So another little trick to cut your new heat break tubing the right length. So always keep one of these original ones that comes with it, because that's exactly the right length, presumably. I guess I could measure it. But that's a good way to ensure that you always get the right length for your heat break tubing. So if it's too short, then there could be a gap where filament can build up there. So you want to make it exactly the right length. If you like this video, please give it a thumbs up. Post a comment if you have any questions or ideas, and I'll try to respond. That's all for now, but more videos are coming, and if you want to see them, please subscribe to my channel and turn on the notification icon if you don't want to miss one. This is Beta Cygni signing out, and keep looking up.